Okay, I'm going to teach you how to do the focus for Ohm's Law and resistivity. For this one, it says to answer with the correct sig figs. So let's go ahead and read this problem. It says a radio operating at 13 volts and a constant temperature draws a current of 893 milliamps. What is the resistance of the radio circuit? Okay, so I'm just going to make a little note of what we know. So we know voltage is 13 volts. We know that current is 893 milliamps, and we want to solve for resistance. So we're going to have to look at the reference table and see if there's an equation that relates voltage, current, and resistance. So I'm going to scroll down here. Here's our electricity table, and it's not these ones, but it is this one, R equals V over I, where R is resistance, I is current, and V is potential difference, and that's what we call Ohm's Law. And we're going to use it a lot, especially when we start solving circuits. So if I write that equation up here, we can just substitute our numbers in. The only thing is there's a catch. See this milliamps? We have to convert that into just pure amps. So we have to convert milli. So again, if you look in your reference table on page 1, you'll look that milli is 10 to the negative 3. So basically what we do is we just take that number times 10 to the negative 3, and that gets rid of the m, and we're just left with the capital A for amps. 10 to the negative 3 is the same as moving the decimal place over 3 spots. So again, that's really 893 amps. So that is what we are going to plug into our equation. So 0.893 amps. And then when I put that into the calculator, I get 14.56 ohms. Now it says to the correct level of sig figs. Well, in this one we have three. My bad, there's 3 sig figs in this one, and there are 3 sig figs in that one. So my final answer should also have 3. So that means we're going to keep this one, and keep this one. But we need to figure out if we round up or down. But because this is a 6, it's going to round it up. So my answer is going to be 14.6 ohms. And that is the answer to the first part. Okay. The next part says, assuming the radio is at 20 degrees Celsius and has 2-meter aluminum wires, what is the wire's cross-sectional area? Okay, so in this case, we know a length. It's 2.0 meters. We know that it's aluminum, which is going to become useful for us later, and we want something that has area. So again, we're going to go back to our reference table, and we're going to look for an equation that has length and area, and it's this one right here. So R again is resistance. This P looking thing, that's called rho, but it looks like a P, that's resistivity, and that depends on the material. So when I said it was aluminum, we're going to have to look up what that aluminum value is in the reference table. And where are we going to do that? Right here. And sometimes we get confused with the 20 degrees Celsius, like it says in here, right here. But that is just really saying that you can use this reference table. So when we use our value for the P value for aluminum, we're going to use that number there. Okay, coming back up. So my resistivity value is what we found in the reference table, which was, it was like 2.82 something. Let me look. Oh yeah, 2.82 times 10 to the negative 8 ohms times meters. Okay, so we know everything else. So this is my equation. We know everything except I didn't say what R was, but R is really what we got from part 1. So I'm just going to write that here. So now we have everything we need. We just substitute it in and then we solve. So 14.6 ohms equals 2.82 times 10 to the negative 8 ohms times meters times 2 meters divided by amps. I'm going to multiply by amps, or no, sorry, not amps, area. I'm going to multiply by area on both sides. And then basically it's just an algebra problem where you solve. And then I would divide by 14.6 on this side, divide by 14.6 ohms on this side. If we pay attention to our units, you'll see that ohms cancels out with ohms, and I'm going to be left with meters squared. So that's going to be in the answer. And when I do all that algebra and math, I get 3.86 times 10 to the negative 9 meters squared. With sig figs, Well, we have 2 sig figs here, 3 sig figs here, and 3 sig figs there, so our final answer will be with 2 sig figs, which is going to give us 3.9 times 10 to the negative 9 meters squared. Now, you'll notice that's a really small number, but again, wires are very small, so the cross-sectional area is not going to be a large number, so you probably will get something smaller. So that also checks out. Okay, so that is how you do the Ohm's Law and resistivity focus.